All right, lesson 9.2. So, continuing on with transformations. Before we do that, though, we're going to do the kickoffs from last time. So, find the image of triangle XYZ under the translation of x, comma, y, map to x minus 2, y minus 5. Now, looking at this, you're going like, what image x, y, z? I don't have a triangle. That is my bad. I deleted this off. But we're going to make the most of it. So, these are the points we're looking at. So we're at the points. We are 2. X here is going to be at 2, comma 1. Y is going to be at 3, 3. And Z is at the point -1, 3. So we're going to map those over to a new point. X prime, Y prime, Z prime. So we're going to subtract 2 from the x, subtract 5 from the y, so I think we're going left 2, down 5. So if we minus 2 would be at 0, minus 5 would be at 4, but -4. If we subtract 3, we'd be, or 3 minus 2 would be at 1, and 3 minus 5 would be at -2. And -1 would take us to -3, and 3 minus 5 would be at -2. So that's where we're mapping them to. That's where we're transforming this by sliding this for this translation of x minus 2 at y minus 5. So today, though, we're going to focus on reflection. So a reflection is a flip. It's an isometry, which we're going to get an exact same shape. So it's not going to change any size or anything about the shape. But we're just going to take it and we're just going to flip it over. Generally, it's across a line. Well, it's going to have to be a line. A point is going to be when we get to rotations, but that's for another day. So what I'm talking about is this. So if we have, say, this triangle, and we have this line here that we're going to flip across. So if we are this far away, we're going to be about that far away on the other side. So again, we're about that far away, so about that far away. And then if we're over here, we're going to be the same on the other side. That we would then connect this up. And my triangle is a little bit different, but you get the idea. It's however far we are away on the one side, we're going to be that same far away on the other. So here being a vertical line, it's only the x's that are changing. Our y's aren't going to change then. Now, if we do horizontal line like this one here, we're only going to change our y's. We're only affecting it up and down. So if we're at 2, 1 here, which is this main point, and our line that we're reflecting across is y equals 1. So remember, y equals is a horizontal line. So we're here at 1 then. So if you think about it, we are 1, 2 away from this line. So it's image then that we transform this by reflection would be 2 away on the other side. So this reflection, we're 2 away from our line. We're going to be 2 away to get our P prime. So it's that same distance. But again, we're a horizontal line. So we're only affecting the y's. The x's don't change here. We're just same distance from either side. So if we're 4 or 2 straight down, we're going to be 2 straight up. Now on this next one, I probably should have had like a little piece of graph paper or something, but we're going to make the most of it. So if we map this out, and I'm just going 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. So my first thing I'm going to do is I'm going to put A, B, and C on here. So A is at -3, 1, 2, 3, 4. B is at 0, 1. So A, B. And then C is going to be at 2, 4. So 1, 2, 4. So if I draw this triangle in, that's the triangle I'm working with. Now, if I grab some other colors here. So the first transformation that we're going to do is y equals 1. So this is just like what we did. So this, and I'm going to go blue. Blue. Grab the different colors. We're going to use the different colors. So we have blue, which is a horizontal line here, cutting across y equals 1. Now, you probably can't tell that's much different, but it is blue, I promise you. So y equals 1. So think here it's a horizontal line, so we're only changing vertically, so we're only going to affect the y's. So however far up we are, we're going to be that far down on the other side. So here we're at -3, 4, but with our line being at 1, we're only 3 up from that line, so we're going to be 3 down from that line, which is going to take us right here to -3, -2. So this would be A prime. So this is our first transformation. Now, B prime isn't going to go nowhere. It's on that line of reflection. It's going to stay on that line of reflection. So it's on the same spot. So if it's on the line of reflection, it's not going to go anywhere. C though, same thing. We were up 4, which is 3 above. So we're going to be 3 below, which is going to be right here at 2, -2. So again, we can connect our shape. And it's going to look like an hourglass. We're going to switch it and go red. So for our next one, though, we're x equals 0. So x equals is a vertical line, and it's 0. So that's this y-axis here that we're going to cut across. So that's our line of reflection. So again, B prime isn't going anywhere. B double prime, I should say, because it's on that line of reflection still. A, though, we would be 3 to the left, so it's going to go 3 to the right to get our A. And again, I'm calling it double prime because this is the second transformation we've done, even though technically it's still translating this first shape. It's not like we're translating the second shape. But see here, we're 2 to the right being at 2, 4, so we'd go 2 to the left to get our C double prime, and so we would connect these like so. So I know it's kind of a jumbled mess because it's on top of each other, but that's the idea. If it's a reflection, so however far away you are, you have to be that far away on the other side of the line. Now, if the line were to say be slanted, well, if our point's right here and we have to go 1, 2, 3 to get back to here, then 1, 2 to be on our line, we would do the same thing. We go 1, 2, and 1, 2, 3 to be at our spot. So we'd be flipped exactly over. So however that needs to be, you're that same distance. So if we're 3 over on the X and 2 over on the Y, we're 2 over on the Y, 3 over on the X. Okay. Now, town officials here at Waterville and Dryden are planning to construct a water tower pumping station along the Franklin Canal. The station will provide both towns with water. Where along the canal should the officials put the pumping station to minimize the amount of pipe needed? So, obviously, straight line is going to be the shortest distance. If you dilly-dally around, you're adding distance to your route. So, making a straight line is going to be the best route here. Now, if I zoom in on this, that's what they're trying to go for here. So they're using the canal as our line of reflection because that's where our pump is going to be. So anywhere along this line is where we're going to have it. So if we reflect D over, that would give us this same distance here that we are over to here. So it gives us an idea to make a straight line. Now, going straight through here to D, again, gives us our shortest distance. So we want P to be where we intersect the canal on a line over here to the image of D at D prime. So that's really what's going on here. So it's the idea of, if you make it a straight distance, the way way the bird flows, or flies, not flows, flies, that's going to be the best, shortest route. So it's like the idea if I'm going to go to Main Street, well, it'd be easy just to do a catty corner across. Now there's going to be buildings in the way, so that wouldn't work. Versus say, well, I'm going to go 2 blocks down and then go 3 blocks over. Well, if I can just go a straight line, that's going to be my shortest distance. And we could prove that with the Pythagorean theorem, but we'll save that for another time. So think of it this way. If, say, the pump was here, well, now we're going to this, and then we're going over to here. Well, we've just made a longer route to go over here and then back versus just going straight there. So by making this flip so that we're identical, the same distance away from the canal, that allows us to make a straight line where we can put our pump. So let me know if you have any questions, any comments, concerns. Please let me know. Otherwise, until next time, we'll talk to you later.